Now, you do get given some information, but you got to go a little further. So what you do know already is that you define these points, right? And then you have these three mutually perpendicular edges, right? Length A, length B. Now, I'm not going to put C on there just yet. The reason why is because when you're working this out, and you're going to go and work out the area by similar cross-section, okay? It is in your interest to know what this distance is and what this distance is, okay? Now remember, the origin is down here. The origin is down here, right? So therefore, the further you go up away from the origin on the x-axis, the diagram even tells you that, I think. Yep, they say C, the length C lies along the x-axis. Therefore, this distance in here, what's it equal to? That's a variable, x, right? If I went right down to the base, it'd be x equals 0. That'll be a triangle. If I went right up to the top where there's the point, it'd be x equals c, right? Because that's x, which is variable, right? That now tells you what this distance is, right? If the whole leg, right, the whole edge is c, then that's going to give you c minus x there, okay? A lot of you got confused because you were not sure where x was. Somebody put it up here, or you didn't. It was just very confusing, okay? Your diagram. Now, where were the marks? Well, again, I need to be able to talk about the similar triangles that are here. You didn't have to prove that they were similar. Say by inspection if you like. Go for it. You're an Extension 2 student, okay? But you still have to provide reasons, okay? So for instance, if I call this cross-sectional triangle, the variable one, if I call it PQR, right? You at least needed to say there are some similar triangles here, right? So for instance, in my case, I would say, looking side on, okay, because what I'm really interested in is going to be this and this, right? Because they'll give me the area of the cross-section. I talked about these two triangles. AOC, triangle AOC, that's the big one, right? And it's similar to triangle QPC. Okay? Now, the real reason is they're equiangular, and that's very easy to see because you've got all those parallel lines, corresponding angles, and so on. I did let you get away with it if you said by inspection, but I did not let you get away with it if your next line down here, and your letters might be slightly different, but on my diagram, I would say something like this. CP equals A on PQ. The vast majority of you left out this line, you didn't say it, you started here, right? And then you said by similar triangles. That is not a geometric reason, right? The reason for this statement is that, what are these things? What are these? They're corresponding sides in similar triangles. So you need to say at least corresponding sides are in proportion or something, right? Like they're not angles, it's what property are you talking about, okay? So this is not sufficient, okay? You actually had to put the full thing in there. Now eventually you then, after this, you get your actual values, which is C on C minus X. A on that PQ is the distance I want, so I rearrange. Okay, now because the proof is literally identical for, rather than this pair of triangles, it's that pair of triangles, okay? You can say similarly. Because all of the reasoning is identical, okay? So I want PR, and that's going to be B on C, right? Is that right? Okay, there you go. So there you go. Those are your two perpendicular edges of my cross-sectional area. Area equals half base height, and then you get to the given result.